Uh, so I'm excited to be here for the developer tutorial. Now, fair warning, as you'll see, I do a little bit of a deeper dive than you might be accustomed to in some of these mastering jumps. I'm the manager of the DOE and reliability team. So I've been with Jump for almost 12 years. I'm kind of always working on DOE methods, these new designs that show up in Jump 18. So for those of you who have used Jump for a while, Bradley Jones may look familiar. For many years, he was in charge of the DOE team. And so when he retired last year, I took over managing the team. But we still collaborate, with each other and then with some other collaborators. And so really these designs that I'm going to be talking about here, there's two papers that kind of discuss these a little bit more. A family of orthogonal main effect screening designs for mixed level factors in JQT, and then a paper that was just accepted, I think in the past week, officially accepted at Technometrics for screening designs for continuous and categorical factors. That's going to appear in Technometrics. These are really the collaborators here for these designs that you're going to see today. So the history and preliminaries. So I think typically when I think back when I was in school and taking a design of experiments class, when we think of screening designs, we're thinking of factors at two levels. Now, I'll also say, recalling from the poll, there were some who haven't used screening designs or maybe weren't even sure what they were. When I think about a design of experiment for a screening design, that really says I have this large group of factors and I want to find out which ones are the most important, right? Or which ones are having the biggest impact on my response or responses of interest, right? So you have your meeting, so you have your scientists and engineers, everybody's getting together. They're saying, well, I think this factor is going to be affecting the response or has a big effect. Everybody has their perhaps pet factors that they think are going to have a big impact. And so really a screening design is intended to figure out which of those are the most important. Now, when these are taught, right, and I think historically, we always think of these as having two levels, right? And they're usually coded as a -1 and a +1. You can think of these as a high and a low. Right? And so it was some form of what we call a fractional factorial design. All that a fractional factorial design means, it's not possible for me to run all different possible combinations, right? If I have 10 of these factors, it's too expensive for me to run the 2 to the 10th all possible combinations. And so then typically the idea has been, if I was going to take a fraction of that, maybe 16 runs, what would be the best way to go about doing that? Now, one of the biggest problems, though, when you start with this screening at the two levels, one of the natural questions is, well, what happens if I have a quadratic or a nonlinear effect? Right? So something's making this kind of U shape. What if something good is happening right in the middle of that high and low? Well, if I'm only using two levels, I'm going to miss that, right? Because a screening design, if all I have are values at high and low, it's just going to be fitting a straight line between those, right? And so really this was always a big concern that, an engineer would come up and say, well, I expect there might be a quadratic effect, right? Or I think that there might be something going on in the middle there. And they'd feel discouraged about using these traditional screening designs, right? And so then in 2011, definitive screening designs kind of came on the scene. Now, one of the big things with definitive screening designs, so it really had this assumption that the factors were assumed to be continuous, right? And so in that case, we were looking for each factor at three levels. But now one of the big key differences, so definitive screening designs versus some of the historical designs that maybe had three levels, was that DSDs, or definitive screening designs, only had a few runs or a few of your experiments at that central value, right? So the main purpose was still screening, right? Because the best way to screen is to have your values at the high and low. But definitive screening designs gave you the chance to detect quadratic effects. And so I think this really turned things on its head from that screening, that traditional screening. So these definitive screening designs, there's more to it than just that, right? It's, you were able to pick up some of these large quadratic effects, but the way they were constructed you actually had built-in protection from the quadratic and interaction effects that were occurring in your factors. Right. And so where that's really useful is that when we think of these traditional fractional factorial designs, you'll hear this discussion about things like aliasing and confounding. And where you can get yourself into trouble is that, well, what if we have an interaction that turns out to have the same settings as one of our effects that's in the design? Well, it turns out in that case that we can't distinguish between the main effect and the interaction. And so these DSDs actually had that built-in protection, right? So they not only could we detect these quadratic effects, we actually had this built-in protection for the interactions. Now, I just want a little bit of an aside here, but so how do we actually decide, right? And I would say in general, if you had a lot of continuous factors and you had the budget, definitive screening designs are really a terrific way to go. On the JMP website, there's this white paper from Christine Anderson Cook that talks about choosing the right design. And so what I really like about that white paper is she talks about a lot of the process about deciding, what do we want to go about doing when we're figuring out where to go in our design. Before we go too far here, as this is a developer tutorial, I'm going to do a much deeper dive. If you're new to DOE, this might be a deeper dive than you'd want to see. That's why something like that, choosing the right design, is a great place to start. If you're not interested in some of these technical DOE details, your big takeaway here is that the designs I'm going to be talking about are really going to be most useful when you have fewer runs and more two-level factors than a DSD. Right? So maybe not everything that I have is continuous, or maybe I don't care about that central value for some of those factors. Right? So really the designs we're looking at here are more about those main effects and maybe the few large quadratics. So I think DSDs have the nice property where you can get not only those main effects, but you can also do a good job of picking up some two-factor interactions and more quadratic effects. But again, one of the big things with the designs here is that definitive screening designs are generally, the cost is about twice the number of factors that you have. Right. So if I have 12 factors, then I might be looking at, 25 to 29 runs. If that's too expensive, that's where these designs today are going to be useful. So where are we going to find these designs? So there has been some discussion of that. Do we want to make these easier to find at a different point? And I will also say they are related to definitive screening designs. Especially, we're going to be looking here at these continuous factors at the 3 levels. So we had almost put them under the definitive screening design menu, but instead, you may think of them as being a little bit hidden here. So we actually have them under classical designs. So what it'll be is that if I can create such a design, so I'm just going to create something here. Let's say if I have 6 continuous factors and 6 categorical. So this is just on the classical screening design platform. What you'll see is that now we can choose the screening type that we have. Right. So now this choose the list of, this would be kind of your true traditional fractional factorial designs. Now, a little bit of an aside here. So this main effect screening design, this second option is when you care about balance. Okay, so this main effect screening design is, instead of, right now I have these continuous factors at 2 levels. If I wanted a 3rd level, so maybe I would do something like a discrete numeric with a -1, 0, and 1. The second option, main effect screening design, that's going to try to balance the number of levels that I have for each. And now I'll talk about this a little bit later, especially towards the end. But when we're interested truly in the main effect screening, finding those most important effects, then typically we're going to want to have fewer zeros. Right? And so the real reason for that is we want those plus and minus ones to get a really good estimate of those main effects. And so in 18, this is where you'll now see this construct a mixed level screening design. And so what I'm going to be talking about here is that, well, you'll see now there's these three different construction types, multiple of 2, multiple of 8, multiple of 16. So again, in this tutorial, the developer tutorial, I'm going to get into the nitty-gritty details as to how we're actually constructing these. And so in fact, I'll actually show you methods that you can construct these. If you have jump 17 2, you can actually construct these kind of by hand. And so we'll talk a little bit then. So what are these? The comments here, what do these mean? Right. So you see this must be a multiple of 2. So it says can accommodate a number of factors that's close to the run size. But main effects can be correlated with second order effects. Now you'll see in general, we have less flexibility with the run size, right? I look at my second option here, must be a multiple of 8, must be a multiple of 16. And so what we're going to discuss is the higher your choice is, the nicer the property of the designs. So here we can see the main effects in the design are orthogonal to groups of second order effects, right? And likewise, that middle one, main effects in the design are orthogonal to the second order effects from the 3-level continuous factors. Right, so we get a bit more orthogonality in this last one, which is useful when it comes to screening. Right, I mean, that means that we don't have to worry about those effects that we didn't consider influencing what our estimates are going to be, or if we have both effects in the model, there's times where we don't have to be as worried about variance inflation and pieces like that. Here at JMP, we do a lot of thinking about what can we build in for you so that if you pick one of these designs, we're giving you the best chance that you can have of finding those effects that you're interested in.